Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And it's called, first take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Narrow Escape Redux by Half-Baked Lunatic, aka David Workman. And here are the rules. We have normal Sudoku rules apply, which means that in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region, which is a box in this case. We have digits in cages must sum to the number in the corner of the cage, and digits cannot repeat in cages either. So, for example, you could have something like, say, 3, 6, and 5 here, and that would be valid because these three digits add up to 14, which is the number in the upper left corner of the cage. And there are no repeats in this cage either. What you could not have is something like, say, 7, 7, and 2, because even though these add up to 16 here, there's a repeat in the cage, which is not allowed. We also have Kropke dots, where digits in cells separated by a black dot must be in a 2-to-1 ratio, and digits in cells separated by a white dot must be consecutive. Not all dots are shown. So, for example, if this were, say, a 6, this would have to be a 5 or a 7 to make sure that these digits are consecutive. If, for example, this were a 2, this would have to be 1 or 4 to maintain the 1-to-2 ratio between them. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. 4 unique digits adding up to 10. It must be 1 through 4. This is 1 through 4. This is either 5, 6, 7, 6, 7, 8, or 7, 8, 9 in either way. So either way, this is in a 1-to-2 ratio with a digit, and it cannot be 1 through 4, so it must be 6 or 8, which makes this 3 or 4, which makes that 3 or 4, and these are the same digit. So this cannot be 6, 7, 8. It's either 5, 6, 7, or 7, 8, 9. 5, 6, 7, or 7, 8, 9. So this is 6 or 8 here, which means this can't be 6 or 8. This is 5, 7, or 9 here. This pair of digits, you cannot have 1 and 2 because that would force 5 cells to be, and this can't be 1 or 2. Huh. So this can't be 1 or 2 because that would force this to be a 3-4 pair for 3 unique digits, or 3 cells, which is not allowed. You can't have 2, 4 either because of the same reasoning. So this must be either 3, 6, or 4, 8. And this is 3, 6, or 4, 8. And whatever digit is here has to be here. So it's 3, 4 because, right, we have a 3 or a 4 here. That means we're missing that there, so it must be there. That means one of these is 3 or 4. This is a 1, 2, 3, 4 in these 3 cells. So this cannot be 3 or 4 here. This is 6 or 8, which makes this 3 or 4. So this is also 3 or 4 here. We have a 1, 2, 3, 4, 6, 8 sextuplet, which eliminates 1, 2, 3, 4, 6, 7, 8 in the rest of the column. So this is 5, 7, 9, 5, 7, 9. That's consecutive with 4, 6, 8, which can be consecutive with 3, 5, 7, 9 there. The rest of row 9 has to be 5 through 9. And it cannot be 6 or 8 here because of the 3, 4, 6, 8 quadruplet in this box. Okay. Whatever pair of digits are here cannot be the pair that's matching that. So this is like the blue pair. And we'll make this then. So that this one cannot be here because both of these digits are here, and that eliminates that possibility. So these must be the blue ones here, which means this is the blue 3, 4. This must be the red value, so this is the red 3, 4 here. Okay. This is the red 6, 8. Since this is the red 6, 8, this cannot be 6 or 8 here, so it's 3 or 4, which means this can't be 3 or 4 here. This is a red 6, 8. Okay, and this cannot be 3 and because that forces this to be 4, and that eliminates all possibilities for that cell. So we have a 5, 7, 9 triplet in box 1, which eliminates 5, 7, 9 in the rest of the box. So it's 1, 2, 3, 4, 6, 8. And this cannot be 3 or 4 because of the 3, 4 pair in the column. So we know the blue 3, 4 has to be either here or here. We're not sure which. This is in a 1 to 2 ratio with 2 other unique digits. So this must be either 2 or 4 here. If this is 2, this is next to 1, 4. If it's 4, it's next to 2 and 8. This cannot be 3 or 4. So this is 1, 2, 6, or 8 here. It could be 3 or 4 here next to, and it could be 1 or 2. It cannot be 6 or 8 here. If this is 6 or 8, that forces this to be 3 or 4. So this could be 1, 2, 3, 4, 6, or 8 there. Blue 3, 4 cannot be here or here, so blue 3, 4 has to be here. So this red 3, 4 sees that cell, this blue 3, 4 sees this cell, so this cannot be 3 or 4, it's 2. Which means 2 can, this is 1 and 4 here. As possibility. So 2 eliminates 2 here. We have a 1, 3, 4 triplet in row 3, which eliminates 1, 3, 4, and 2 in the rest of the row. So it cannot be 1, 2, 3, 4. 1, 2 cannot be 1, 2, 3, 4. This has to be 5, 7, and 9 here for the remaining digits because we have a 6, 8, 6, 8 pair there. This cannot be blue. So blue is either here or here. 6, 8, 6, 8 is next to 5, 7, or 9 in to be consecutive. 6 and 8 is consecutive only with 3 or 4 here. So this is that. 3 is guaranteed to be one of these digits, which means this cannot be 3 here. Red 3, 4 is one of these. Therefore, where is the red 3, 4 in row 7? Cannot be here, cannot be here, so it must be here. So this is red 3, 4 guaranteed. So it's either 1, 3, 6. This can't be 6 though, so this would be 1 and 3 with 6 there potentially. It could be 1, 4, 5, and 5 could be here. This would be 4. You'd have 1 or 5 there. It could be 2, 3, 5, with 2 and 3 being there. So we're guaranteed this is 3 or 4 here. Remaining digits in box 7. We have 1, 2, 5, 7, 9. But this cannot be 5, 7, 9 because of the 5, 7, 9 triplet in column 1. And this can't be 4, because if this is a 4, it would have to be between 5 and 5 to be consecutive, and that's not possible to be in the same. So this cannot be the blue 3, 4. This must be the blue 3, 4. So this becomes a 3, 4 pair. We have a 6, 8 pair in box 1, which eliminates 6 and 8 in the rest of the box. So this can't be 6 or 8. This is 1 or 2, which eliminates 1 and 2 here. This 3, 4 pair eliminates 3 and 4 here. So this must be 1, which makes this 4. So the blue 3, 4s are 3. So these are all 3. We don't know that's the blue one. Okay, so then we can remove that. We can remove this. The blue 6, 8 has to be 6. So that means these are 4. This cannot be 3. This cannot be 6 here. So this is 8, which means this has to be 7, 8, and 9 to be consecutive with 8. That leaves this as a 5. So this cannot be 5. This is guaranteed to be 1 and 4, which forces this to be 5. That eliminates 1 here, so this is 2, which makes this 1. These obviously can't be 3 anymore. This 2 and 4 eliminate 2 and 4 here, so it's 1, which eliminates 1 here. These can no longer be 4 because of the 4 in the region. This has to be a 3, 4 pair. This 3 eliminates 3 here, so this is 4, which makes that 3. These 2 digits plus this digit must add up to 16, so it cannot be 7 and 9. So it must be 5 guaranteed here, which means this can't be 5. So it's 5, 7, and 4 to add up to 16, or 5, 9, and 2 to add up to 16. Okay. Remaining digits in box. Okay, this 6 eliminates 6 here, so this is 8. This must be 7 or 9 here. This is 5, 7, or 9 here. 5 eliminates 5 here. Where is the 5 in column 2? It must be one of these 2 cells. So this cannot be 5 here. We're guaranteed, so this is either 5, 6, 7, or it's 7, 8, 9 in some order. So this can never be 7 here. We're guaranteed a 5 here. This can't be 5 because of the 5 in the column. What else do we have? These add up to 14 without a 5. So what are the possibilities? 1, 4, 9. That's except that eliminates all possibilities for this cell. 3 cannot be here, 3 cannot be here, or here. So 3 has to be one of these 2 digits here. Okay, that's interesting. 3 is also one of these 2 digits here. 149 is not possible. 158 is not possible. 167 could be possible. 239 is not possible because that would force this to be 4 and 4 and have a duplicate in the box. 248 is not possible because of this 2, 4. That would eliminate all possibilities for that cell. No 257. So 2 is not possible to be in this cage. So we have 167 as a possibility. 3. Well, you can't have 3 and 4 together. You can't have 3 and 5 together. What about 3 and 6? 3, 6, and 5 would require that to add up to 14. So this cannot be 3. which means this has to be 3 here. So this is 3, which makes this 6 and 6. This is then 8, which makes this 6. So this is 5, 6, 7 here. That makes this 9, which makes that 7. 8 is next to 7 or 9, but this can't be 7 because of 7 in the column. So this is 9, this is 5. That eliminates 5 here. Where is the 5 in box 4? Cannot be here, so it must be here, which makes this an 8. So this is guaranteed to be 3. Remaining digits in row 8. Okay, this can't be 5. So this must be 2, 5, and 6 here. So we can't have 3 as the lowest digit, and 4 as the lowest digit, and minimum must add up to 4, 5, and 6, which is 15. So this is guaranteed to be 1, 6, 7, which forces this to be a 4, which makes that 1. This can't be 6. This can't be 7. 5 eliminates 5 here. So this is not the red anymore. We can remove these colors. We can start coloring 7 9s potentially. We're going to make that orange and this red. So that makes this red here, which makes that orange. This red eliminates red here, so this is orange, which makes this one of these a red. This can't be 7 because of the 1, 6, 7 triplet in the row in the column. This can't be 7 because of the 7 in the row. Remaining digit in row 6. We have 1, 2, 6, and 9. This can't be 1 or 6, so this is 2 and 9. 1, 6, 2, and 9. Obviously, 1 cannot be either of these. This can't be 2. Therefore, we have a 2, 6, 9 triplet, which eliminates 2, 6, 9 in the rest of the row. This can't be 6. This is 1, which eliminates 1 here. Okay. Both red and orange are here. Red and orange are here. So red has to be one of these. Cannot be here. So it has to be one of these two. Orange cannot be here, so orange is one of these 3. This can't... Remaining digits in box 5. We have 2, 4, 8, 9. Okay. Okay. What else do we have? Remaining digits in column 9. 6 through 9. 6 has to be one of these 2 digits here because it can't be here. So this can't be 6 here. 6 cannot be here. Where is the 6 then in column 9? It has to be here. So this is 6, which eliminates 6 here. This cannot be... could be the red 7, 9. Where is the 8 in box 5? It has to be one of these 2 digits because this can't be 8 here. This can't be 8 because of the way that it adds up. So this is 8 here, which means this can't be 8 here. So 8 in row 4 has to be one of these 2. 6 eliminates 6 here, so it's 7 and 6. This can no longer be 7 or 9, so it's 8, which means this can't be 8 here. This can't be 8. This has to be the red 7, 9 then. So this cannot be red. This is the orange 7, 9. Remaining digits in box 3 are 3, 5, 6, 8. And this can't be 3 or 6, so this is a 5, 8 pair. 5 eliminates 5 here, so it's 8 and 5. This can't be 6, so this is 3, which makes that 6. Okay. Remaining digits in column 7. We have 1, 2, and 4. Well, we have a 1, 2, 4 triplet in rows 4, which eliminates 1, 2, 4 in the rest of the rows. So this is not 1, 2, or 4, it's 5. Okay. This has to be 2479 as possibilities. Okay, remaining digits in row 2 are 1, 2, 3, and 8. This can't be 1 or 3. This can't be 1. This can't be 3. Where is the 3 then in row 2? It has to be here. So this is 3. Remaining digits in column 5. We have 2, 5, 8, 9. 8 cannot be here because of the 8 in the row. This can't be 5 anymore, so this is 2 or 9. Where is the 8 then in column 5? It has to be here. So this can't be 8 here. This can't be 8 here. We don't know which one of these is red, which one of these is orange. Okay. One thing you cannot have here is 2 and 9, because that would eliminate all possibilities for this cell. So this can never be 9. Okay. If this is 2, that's 5 and 9 here, then this is 9. Okay. 6 cannot be here because of 6 in the column, so this is 2, which makes this 5. That makes that 6. 2 cannot be here, so this is 8, which means this can't be 8 here. 2 and 8 cannot be here, so this must be 8 here. 5 eliminates 5 here, so this is 9, which makes this 5 and 2 to add up to 16. So this must be, the red must be 9. And the oranges have to be 7. So this can't be 9, that's 2, which makes this 1, which makes that 2, which makes that 1. 2 eliminates 2 here, so it's 1 and 2. This can't be 1 or 2, so it's 4. This 2 eliminates 2 here, so it's 9, which makes this 4. This can't be 2 or 4, so it's 1. 9 eliminates 9 here, so it's 2. Which forces this to be a 7-9 pair. This cannot be orange. This must be the red one. This 9 eliminates 9 here, so this is 7. Which means this can't be 7 or 9, so this is the orange. So this must be 7. That makes this 9. This 4 eliminates 4 here, so it's 2 and 4. This has to be 9 and 9, and this remaining digit is a 4. Play it again, Sam. Yeah, fairly straightforward. Definitely on the easy level, I would consider. Yeah. Pretty straightforward again. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.